Section 6.4, homework problem number 14. So use the fact that we can rewrite the division problem as a multiplication problem. So just like subtraction problems come from addition problems, division problems come from multiplication problems. And so for example, just give you 2 times 3 equals 6. And you can turn this into two division problems. 6 divided by 2 equals 3, or 6 divided by 3 equals 2. Or in other words, if we are given any, let's say 8 divided by 2 equals 4, and we can turn this back into multiplication question. It's 2 times 4 equals 8, or 4 times 2 equals 8. So we could, whenever we're given a division problem, we can turn that into a multiplication problem. So here we have, if we are dividing these two fractions, how do we turn this into a multiplication of fractions? Because we already, in chapter 5, we already know how to multiply fractions, which is multiplying straight across. So that's what we're going to use that to reverse the division problem to a multiplication problem. Okay, so the answer, whatever that is, it could be a whole number or a proper fraction, but any whole number, let's say 6, can also be written as a fraction, 6 over 1. So it doesn't hurt if we consider the answer as a fraction, something over something. So because that makes things a little easier. So that's what I was doing. Instead of just one question mark, I'm going to put it as what's the numerator, what's the denominator. And again, similar to this example here, when you multiply the answer and the divisor, you're going to get the dividend. So when I multiply these two, the answer fraction and the divisor fraction, which is right here, times the divisor, it's going to give me 7, sorry, it should be this one here. What times 3/5 equals 7/11? I'm going to actually put that. And in order to do that, so here I'm going to explain the process. So what fraction times 3/5 equals 7/11? And notice the multiplication, although we don't know what the numerator denominators are, we can still multiply straight across, which means top times top, bottom times bottom. So to multiply the left-hand side, we just do the top question times a top question mark times the top number 3, and make this a long line, a big fraction, long line to represent one single fraction, and question mark times 5. So this tells us what times 3 what times 3 over what times 5 equals 7/11. So notice that in that case, we can possibly set then to be equal what times, or in other words, what times 3 equals 7, and what times 5 equals 11. Set the numerators equal to each other, denominators equal to each other. But the problem is, what times 3 is equal to 7? We're not going to be able to get a whole number. We want the fractional answer, we want the top to be a whole number and the bottom to be a whole number. But if we do that, it's not a whole number. So we can do some modification here, because the problem that we cannot solve this question, what times 3 equals 7, is because 3 doesn't go into 7. So let's make a number here such that 3 goes in there. So apparently, if you want a 3 to go into that number, you have to have a 3 in there. So I'm going to go ahead and multiply by 3 there. And if you multiply the right side by 3, of course, this changes the problem. But what we're going to do is here, so that just gives us an idea. So here, if I want to be able to solve that equation, what times 3 equals that number, this number has to have a 3 in there. So we're going to go ahead and multiply by 3. But instead of multiply another 3 here, we actually, because the right-hand side is fraction, we know we can turn any fraction into its equivalent fraction by multiplying the same number. So we're going to multiply the bottom also by 3. That way, I can, now when I set the numerators equal, I have what times 3 equals 7 times 3. So I'm going to be able to figure out, okay, well, the question mark is 7. But of course, we're not done yet, because we also have to make the bottom work. Right now, the top works, but the bottom doesn't work, because what times 5 equals 11 times 3, which is 33. Again, 5 doesn't go into 33. So that's a problem here. So we also need to, in order to get a whole number answer, we have to make sure the right side also is a multiple of 3. So we're going to have to need a times 5 here. So we're going to multiply the bottom by 5. Again, if you want to keep the equivalence of the fraction, we also have to multiply the numerator by 5. That way, so if you multiply both top and bottom by 3 and 3, 5 and 5, which is equivalent to multiplying 15. And that should still be equal to 7 over 11. But the good thing is, now when I try to set the numerators equal to each other, denominators equal to each other, I can solve the problem now. So for example, the top, what times 3 is 7 times 3 times 5. You can cross out a 3, so the question mark, the top question mark is 7 times 5, which is 35. And the bottom, what times 5 equals 11 times 3 times 5, I can cross out a 5, so that question mark is 11 times 3. So that's the idea why we are multiplying both top and bottom by 3 and 5. So you can go back to my explanation here. So we end up with something like this, which is what I showed you. So by comparing the two fractions, we know the question mark. So what I, instead of solving them separately, what I did in the explanation was, so we're just gonna say, okay, so what is this question mark? And we could cross out, let's see, we do. So what we did is to cross out this 3 from the top and this 5 from the bottom. So cross out 3 and 3 from the top and then 5 and 5 from the bottom, which tells us pretty much the same. So the top question mark is going to be 7 times 5. The bottom question mark is 11 times 3. So when we put them together, so again, top question mark is 7 times 5. The bottom question mark is 11 times 3. That's what I did a minute ago. But we're going to keep it as a fractional form, not writing them separately, because the answer should be the fraction question mark over question mark. So now when we look at this answer, we know it's 35 over 33. But if we keep it in this format, and you can see 711, it's exactly that number right there, first the fraction. And 5/3 instead of 3/5. And notice that it was 3/5, but we changed it to 5/3. In the answer, we got 5/3. So that tells us, okay, so this is the what we call reciprocal or the inverse, so 5/3. And that was the original number, 711. But the good thing is the division is gone. It's multiplication. And so we can split this as two fractions, 711 times 5/3. And notice that by the multiplication rule of fractions, we multiply straight across. 7 times 5 is 7 times 5. 11 times 3 is 11 times 3. But we are reversing that multiplication rule to split it as the product of two fractions. And so from this process, we could see that how do we solve for the solve this division problem? We could take the first fraction and change division to multiplication, and then flip the second fraction. So there's a quick way to remember this rule, which is called keep, change, flip. Keep means keep the first fraction. Change means change division to multiplication. Flip means to flip the second fraction. And we will talk about why this works using the definition of in section 6.5. But right here, we did not use that. We just used the multiplication rule by converting division problem to multiplication problem, and then using the multiplication rule, we were able to see figure out the answer, and which by looking at the answer, we could tell this division problem can be solved by changing it to multiplying its reciprocal.